Hello there. So yesterday we practiced plotting points on a polar coordinate plane, which involved a radius and an angle theta. So as we plotted these, say we had 3 at 135 degrees. I don't have a polar coordinate grid, but that's okay. We started here at the pole and we went out a radius of 3, and then we rotated around 135 degrees, and we plotted our point and drew the vector out like that. Today, what's going to happen is they're going to give you equations. It'll either be an equation involving just a radius or an equation that involves just the angle theta. So let's get busy and see how we deal with those situations. So our first example here says graph the polar equation r equals 2.5, or a radius of 2.5. Well, let's think about that. Yesterday, it was a radius and an angle theta. So in this case, they're just giving us a radius and no angles for theta. So what I would interpret this is as theta can be any, sorry about that, any angle measure, right? So if I have radiuses of 2.5, theta, the angle, can be anything. Well, if we interpret it that way, let's see what would happen. So I will go ahead and count out my radius of 1, 2.5. So there's my radius at 2.5, but my angle theta can be any angle at all. So my angle theta can be pi over 12, pi over 6, pi over 4, going to pi over 2 even, 3 pi over 4, 11 pi over 12, 13 pi over 12. Angle theta could be 4 pi over 3. It could be 19 pi over 12. It could be 11 pi over 6. Or it could even be 2 pi. So if they give me a radius of 2.5, theta can be any one of these angle measures. So if I graph the equation r equals 2.5, it's going to create a circle with a radius of 2.5. And that's how you graph an equation that's just r equals. It'll always create a circle with whatever that radius is. Okay, I hope you find that to be easy enough. Let's look at the other way. What if they gave us an equation where it's theta equals an angle measure? Well, if we take a look at that, again, I'll start with what we know is true. It's a radius and an angle theta. They're now giving us the angle theta. So I would interpret this as the radius can be any measure, right? So if that's the case, let's see, here's our coordinate grid here. Like we got, here's 5 pi over 6. So 5 pi over 6, I would rotate around to 5 pi over 6. And our radius can be any value. So we could have a radius of 1, 2, 3, 4, 5, 6, 7, going in that direction there. But remember, when you plotted your points, you also had like negatives, and then it would go in the other direction. So if I had a -2 could be my radius, that would mean -2 is over here. It could be a -3, which is over here. So my radiuses could even go in this direction here. And that would be the graph of the line theta equals 5 pi over 6. So theta equals 5 pi over 6 creates a line. So I want you to remember, if it's a radius equals, that always forms a circle when you graph it. If it's theta equals an angle, that's always going to create a line. I think this is very helpful to remember, and it tells you what's going on. I have angle theta of 5 pi over 6, and the radius can be any value. So I just connect all the dots with all the radii, and I form a line. Okay, one more. We got an application problem here. So let's see what we got. An air traffic controller is tracking two planes that are flying at the same altitude, right? Visualize that. Two planes are the same height. The coordinates of the planes are at 8, 60 degrees. So let's see, 8, 60 degrees. What do we got here? 1, 2, 3, 4. Okay, so I'm going to count by twos, right? I only have 4 rings or 4 radii. So I got to count by twos to get to 8. So 8 at 60 degrees. So that would be here 8 to here 60 degrees. There is the location of plane A. And then plane B is at 4 at 300 degrees. So let's see, 300 degrees, and it's 4. I'm counting by twos. Remember, my scale is by twos. So it'll be right there. There's the location of plane B. Let's make those marks here. This is a 4. This is an 8. The question is, how far apart are the two airplanes? Well, let's draw that in. How far apart are the two airplanes? This, I think, looks familiar. I have this triangle here. Focus on that. I know a side length of 4. I know a side length of 8. I know that this rotated 60 degrees. I know this guy rotated 300 degrees, but couldn't we also interpret it as it went 60 degrees in that direction as well? So can't we call this angle 120 degrees? And remember, if I have a side angle, side situation, I can use the law of cosines. So this is very similar to what you did in 8.1 when we used the law of cosines to solve all those problems. So now I can set up x squared equals this side squared plus the other side squared minus 2 times the product of the two sides times the cosine of the included angle, which is 120 degrees. And we go ahead and solve this using our graphing calculator. We type that in very carefully. 4 squared plus 8 squared minus 2 times 4 times 8 cosine 120. And we get, oh, I forgot the square root of that. The square root of that answer is roughly 10.58. So how far apart are the planes? We would say the planes are approximately 10.6 miles apart. So now we're just going to take what we learned in a previous lesson, apply it to what we learned yesterday, and then there we go. We can solve a new problem. All right, everyone, that's it for today. Again, I put the practice worksheet in today's folder. It's really not assigned until tomorrow, but if you want to get started on it right away, that way you have time to email me if you have any questions at all, and then it would give us time to get back together and work out whatever your problems you're having. So again, thank you very much. Keep up the good work and enjoy the rest of your day. Bye bye.